Those cases can be very confusing to look at to start to filter through what all those different cases mean. So let's look at some examples where we'll see this in practice. Keep in mind that in each of these cases, what we're considering is our value for x approaching either positive or negative infinity. So we're considering those extreme values, which means we're only going to consider the leading term in both the numerator and in the denominator. So as x approaches negative and positive infinity, our function is going to be approaching 10x over x. From there, we look at simply reducing the expression that we have. X over x is going to cancel, leaving us with 10. So as x approaches positive or negative infinity, our function value is approaching 10. This is something similar to case 1 and tells us that we have a horizontal asymptote defined by y equals 10. In example 9, start off the same way. We're considering x approaching positive or negative infinity, which means our function is approaching 20x squared over 4x, the leading term in the numerator divided by the leading term in the denominator. This will reduce to 5x, meaning what we have is x to the first power. So this would be something like case 3. Since we end up with x to the first power, we know that we'll have an oblique asymptote. What we need to do is find the equation in y equals mx plus b form, so that slope-intercept form, that defines that oblique asymptote. In order to do that, we have to divide our two functions. So we'll start off by multiplying by 5x. And then we'll subtract those results from the line above, which will give us 34x. And then we'll drop down that next term and then multiply by 4. Oh, sorry, let me go back. I made a point of saying that we're going to subtract, and then I didn't do that. So we would be taking negative 9, and that would actually be plus 25, which would give us 16x minus 20, which is why we'll want to multiply by 4 to get 16x minus 20, and then subtracting will leave us with a remainder of 0. But really all we care about are just these first two terms here, regardless of what our remainder is. So our oblique asymptote will be defined by the line y equals 5x plus 4. In example 10, again, if x is approaching both positive and negative infinity, then our function is going to be approaching, in this case, x to the 4th power over x squared. Reducing would give us x squared. So in this case, we don't have x to the 1st power, we have x to some power larger than that. So this would be the same thing as case 4. We have no horizontal or oblique asymptotes. So we have no line defining our end behavior. Instead, the end behavior of this function will follow y equals x squared. Meaning right now we don't know a lot about what's happening in between, but at our extremes, as x approaches positive infinity, our function is going to be increasing. As x approaches negative infinity, our function is going to be increasing. In example 11, we'll look at another case here. Again, x is approaching positive or negative infinity, meaning our function is approaching x squared over x cubed. Reducing is going to give us 1 over x. Since the only variable that we have left over is in the denominator, this is going to be like case 2, regardless of what power that variable is raised to. So in this case, we have a horizontal asymptote occurring at y equals 0.